I didn't think it was gonna run tonight. I'm gonna be completely honest with you. I did not think it was gonna run at all. I thought I was gonna have another issue. Thought I was gonna have a massive oil leak. It idled, it revved, it started. So next thing is I want to see forward, reverse, neutral on this. For right now, you're just gonna hear the multimeter like that whenever we have conductivity. Let's get this on there and let's go that way. So we shouldn't be in neutral anymore. Wait, hold on. Okay, so that's neutral. So neutral is bottom right. That should be drive, which should be this pin. It is active, it just, conductivity is not high enough to actually, there it goes. And so this bottom pin down here, I'm assuming is reverse, so let's try that. Ooh, it didn't. That's neutral. That should still be drive, yeah, so neutral, and that should be reverse. Oh, it didn't go in. There it did. Okay, there it went. So I guess it just wasn't rotated enough to actually get into reverse. So that should be neutral. Yep. And then let's put this into there. So that should be drive. Ooh. There it goes. Okay, so we just have to make sure that we rev the engine, or I guess it would be an idle. So this would move a little bit and lock into the actual gear that we're in. So let's put that back on neutral, and then this should go freely into neutral. Cool. We now know that we have bottom left is drive, top left is neutral, top right is reverse. And the idle probably should help us get into that. Now what? Okay, so now we're gonna work on the hybrid system of this, and since we have our switch, which should be non-powered, which I'm just gonna verify that. Switch right here is green red, and I can't tell if there's a ground, but it's probably a case ground. That actually makes the job of this a lot easier, because now I don't have to do a relay conversion between the light switch, or because this is supposed to be for a light indicator. Ground is supposed to go to the rest of the ground, which it does, and then the switch is supposed to go through a bulb back to positive. That way, so when you put in the gear, or any of the three options for neutral or reverse, it will illuminate that light for it. But since we're not going to be using it as a 12-volt system, it should be fine. It should just be a switch. So this is the 3 kilowatt electric motor. You can get these things super cheap off of Amazon and eBay. I went with the 3 kilowatt model. They also make, there's a bunch of them. They make them in like 250, 500, 1000. I think it's 750, a 2000, a 2500, and a 3000 watt one, which is this one, which is 72 volt, and it's rated for 45 amps. I don't think we're going to be able to pull 3000 just because I'm going to be using some batteries that should be able to at least pulse get it there. And the connector looks like this, which should look familiar to some because it's the same connector for Ryobi batteries. So we're gonna have a string of these because they're each 18 volts, and 18 times 4, 72. Perfectly fits what we're working with. Let's clear some space. I'll reconnect this up. So now I will reset up the battery array. So we're going to be doing something a little bit funky. So catch you back up because that camera died. These batteries have, I believe, 5 cells in series at 3.7 volt. Yeah, it should be about that. 3.7 times 5 is about 18. We have a parallel set of those 5 batteries. And so basically when you put more in parallel, it gives you a higher capacity. It also gives you a higher current, peak current. And so for these bigger ones, like the 4 amp hour and the 6 amp hour, even though they're the same size, it's different quality of cells, which these have higher quality cells, so it has a higher rating. So these should be able to take the current fine. This should also, this is another 6 amp hour. But these guys, since they're only one parallel, these can't take the current as well as these can. So we're putting these in parallel with each other as if they're wired internally like these 3. So let's get all of these clips on there. And right side is positive. Now these are wired now in parallel like these are internally. So now we're just gonna start daisy chaining them. If I check 2 farthest apart terminals, we should have 72. So here, so there's 18, 18, about 19, yeah, about 18. Okay, and then we're gonna go across the whole pack, 18 times 4. Okay, so we're a little bit above 72, which is fine. So this is our negative, this is our positive. I'm actually going to run this through the switch here. I'm gonna put it this way, and now when I push the rubber down, completely covers it. All right, so these don't accidentally touch, and we don't want them to, and that is off. So now, I turn the switch, and there's our full voltage. Obviously, we're gonna have better wire, because I'm getting a lot of resistance here, as you can tell, considering we read almost 80 before. Like I said, not final setup. So now, bring all this stuff up here, hit on. Turn the switch on, we're in forward. So now when I push this, that motor should turn on. Yeah, okay, cool. Yeah, so it's rated for almost 5,000 RPM and 3 kilowatt. So let's turn that off and that off. And so what we're working with now, we need to figure out which one of these is forward reverse. So this one is throttle speed. And so this guy here, our reversing button, let me see if I have that connector, which I should. It's only a 2-pin. Yeah, I only have it in male connectors. Okay, which is fine. We can do a splice. But what I need to check is this powered or not? Everything's off, so there shouldn't be anything. So turn that switch on. Okay, so it's a 5-volt signal. Okay, and so no connection is forward. And then if we bridge it, which I guess if I just set this to reverse, there's a simpler way we can test that. 2 pins in there, I'm gonna turn on reverse. So if it's just not connected, it's forward. If it's connected, it's in reverse. Okay, so about 4.5 volts. So turn this off. Cool. 0 volts. And then if I turn that on, it goes back. Awesome. So great. That actually should be really simple if I want to make this work right. So now we need to judge, do we want this motor to be active when it's in forward, neutral, or reverse? So obviously if this is the reading forward, it's going to be in forward. If it's in reverse, it's going to be in reverse. If it's in neutral, it's going to be in neutral. But we don't necessarily have to have that for this. We can wire this whatever way. If we were being stupid, we could wire this for reverse when this is in forwards. We could. It'd make no sense, but we could. So I think it makes sense that when this is in forward, this should be in forward. When this is in reverse, this should be in reverse. But the real question is when this is in neutral. So should we have it to when it's in neutral? Should it turn this off? Like, should this operate like the key switch? Like, turn this actually off? Or should we have it in forward, like a EV only mode? And that's kind of what I think I want to do. When it's in reverse, it goes reverse. When it's in forward, it goes forward. When it's in neutral, it will still go forward. In case that battery dies right there for some reason, we could actually run it in EV mode and jump start the motor, which since this actually doesn't need a battery to run, that is a pretty good idea. Only thing though I don't know about is what happens if these batteries die. How will the feedback power go from, because obviously this will still be spinning, because that will still be spinning, because it'll be geared to the same shaft. Will it try to, you know, what will it do? Will it try to charge the batteries? Like, will it give current backwards? Almost hope not. That'd be really cool for like regen and stuff, but like that would be an always on kind of regen, which is not the greatest. I have thought about setting this up to where we have a boost converter boosting this 12 volts up to 72 and then just have it across the series here, but there's whole reasons why that's not a good idea. I could buy a BMS for this, but it's kind of hard to find a BMS that wants 18 volts per module versus 3.7. And the reason why I need the BMS is these will charge differently because you want the same amp hours to charge evenly. Like this 4 amp hour will charge faster than the 6 amp hour. And if this finishes charging before this one does, this one is still going to be drawing current and this one won't. So it'll be trying to push current through something that doesn't want to have current run through it. And we don't want to do that because that could cause these two to potentially blow up. But since these are 2 amp hour and these are 4 amp hours, these three should relatively charge at the same rate. Even though this is 2 amp hour and this is 4, since these are in parallel, this is essentially a 4 amp hour battery. I'm going to need to have a manual way to disconnect this motor from power. Like say these batteries, you know, say we have a system that like when this turns off, like this is too low of a voltage, it turns off this system. We need to make sure there's a way that this isn't going to feed back into this. So we might have a contactor. Actually, we do have a contactor. We have the old starter solenoid contactor. Actually, this would be perfect. Yeah, so this is what's going to turn our EV mode on. Okay, cool. So we have that. Yeah, by the way, when this is off for the battery pack, it should make sense that when we turn that on, this won't do anything. Oh! I guess we had some charge left in the capacitors that are in here. Interesting. Actually, what I want to see is I want to see how much voltage is coming through the switch. I'm assuming it's only 5 volts. Okay, so the actual key switch is running the full battery voltage? I guess it is. I wouldn't have assumed that. I would assume that would just been a logic level thing. You know, actually good on them for having some way to fully disconnect the battery, but I wouldn't have assumed they would have implemented it like that. So now I want to make a connector for this, and I want to think about how we're going to make the throttle pedal work. Obviously for this motor here, we have this throttle cable linkage that when I push this, the slide valve inside of the carb is actually sliding up. and back down, and up and back down. For this guy, we have the foot pedal, and this is digital. There's a few ways I could do this. If we wanted to go full electrify everything, I could pull out the spring in here, put a lower spring rate, and replace this cable with a servo motor or with a linear actuator of some kind. It would have to be quick enough and strong enough to be able to pull up the slide valve and push it down if we need to. But that's one way that we could electrify or digitize the carb. The other option, we make this analog. What that would imply is we have this cable like screwed in like behind this plate right here, and we have it some way where when we push this down, it pulls the cable through. That way, so we would have electric pedal pulling the physical cable. Oh, so the throttle pedal is 3 pins, which means it probably is a potentiometer. Easy way to check that. Makes sense. I mean, I wish there was some way to adjust this. This is no interface at all, so it is what it is. What are we going to do? Are we going to electrify or digitize, aka put a servo motor on the carb, or are we going to somehow run the cable through this? Because no, I don't want 2 throttles. I could have 3 pedals, a gas pedal, an electric pedal, and a brake pedal. There's no clutch, it's automatic. Semi-automatic. That is a good question to ponder about how I want to do that. I would like it to where it's 1 pedal though. And I would like a light for drive and reverse. I would like a light for all 3, forward, reverse, neutral. So I'd like to have a pin for each of those spots. But if you notice, we have 3 wires coming out of this and only 2 wires on here. Is not what we're looking for. So let's look at the other connector I was holding, which has 5 wires coming out of it, right where our neutral pin is, which is this top left one here. We don't have a pin there. The option is either move one of these pins to this one or just move one of these pins over, and forward is probably that bottom one right there. And so we need to add a reversing pin to this bottom corner over here, because remember it's mirrored. Okay, I'll just take the yellow one then. Right as I did that, pin came right out. Now if you can see that, you see that little tab that sticks out there? That's what's grabbing on. Bottom left, should be bottom right. And if I push that up, oh, nice satisfying little click. And now this should be fitting fine. And this also does mean that if the motor does not go into gear correctly, this will not turn on. So we won't be powering the output of that because this will have the same output. So if this tries to turn on when this isn't in gear right, it won't happen because that switch will not be on. It will not be in the right spot. Forward and neutral, we want, I'm just gonna twist them together for the sake of memorizing that, but cool, on. And then back, it just turns it off, which is really good. I'll have to take my foot off the gas pedal on this to be able to switch gears anyway, so that'll be fine. Oh, that just fits in there. Cool. So now, when I turn this on, this should be in high mode. Cool. And then where is the shifter? Put this on. Just want to make sure. There we go. So now we're in gear, and so that should be drive. So this should still be high mode. Let's put back neutral. It should still be high mode. Cool. Now this should be reverse. And it's in reverse. Awesome. So now we have the transmission shifter and the gas pedal. So actually, if I put this in reverse now, sorry, neutral, this turns off. And if I repress, cool. If I go high, yep, and that's in reverse now, and this should be. And reverse off also. Oh, actually, you know what I might do? I might splice this ground line off from here, because this does have the right connector. I will have to do the same depinning. We'll do that. That way, so it's a direct plug into this wiring harness kit. It's cool. So I actually have a connector for that now. Okay, so now these two electrically work with each other. Awesome. Okay, so it's been about 2 weeks since I've last worked on this, and it's not because ordering parts or anything, it's purely because I've been lazy on working on it. I've thought a little bit more about how to do the carburetor and the choke slide, and I am going to actually end up putting servos on both the choke and on the slide, just to make it all electronic, make it all digital. That way, so if, you know, a kid that's really little that probably shouldn't be going really fast is on this, we can actually set like a speed limit, and we can lower their throttle, like their max throttle. If we put a servo on the choke, we can figure out how to maybe do an automatic start, like, you know, push button start. I think that'd be kind of fun. So yeah, I'm gonna go that general route.